If you are very observant, you would have noticed this curious hole that is in all passenger planes and large military aircraft. This is the exhaust of the auxiliary power unit, or known by its acronym in English, Auxiliary Power Unit. The auxiliary power unit is a turbine of much smaller size than those that propel the plane, and it is located at the rear of the fuselage. The auxiliary power unit of a Boeing 747-400 is as big as a utility car and can cost more than $1 million. It will make the plane self-sufficient, providing electrical power and bleed air for many different functions, such as starting the main engines. And we will see all this in a new video from Aviation World. These devices are actually small jet engines. Being small enough, they can be started electrically. Therefore, these auxiliary power units use the energy from the battery or from a ground electric cart to spin their engine. Then, it will consume the same fuel that powers the main engines. It's something similar to starting a jet engine, only that these are initially ignited with air coming from the auxiliary power unit, which would be one of the functions, the starting of the main engines. But returning to the start of the auxiliary power unit once started electrically, this movement will be used to move the electric generator it has incorporated. When the engine start sequence begins, some pressurized air from its compressor will be stolen to supply purge air or bleed air for the engine start, as we had said. Turbine engines must accelerate to a very high rotation speed to provide sufficient air compression for self-sustained operation. Air conditioning systems can also be operated with air coming from the auxiliary power unit. After the flight, the auxiliary power unit is started before the main engines are shut down. In this case, the auxiliary power unit is started by air instead of the electric motor, with pressurized air supplied by the main engines, which are still running. For takeoff, the bleed air from the auxiliary power unit can be used to supply the cabin air pressure system and thus reduce the load on the engines, that is, not steal the energy that would take power away from the main engine and result in a significant reduction in the runway length required. If auxiliary power unit bleed air is used to pressurize the cabin or the air conditioning on normal takeoff, the maximum engine temperatures will be lower during this period. This increases the engine's lifespan, as the maximum engine temperature is the main factor in its lifespan. During flight, in case of main generator failure or a complete engine failure, the auxiliary power unit can be used to replace the faulty engine generator. Current legislation indicates that a two-engine aircraft must use the auxiliary power unit after the loss of one of the power plants to continue having two independent sources of electrical energy. It is significantly cheaper to replace an auxiliary power unit than an engine. In case of emergency, if all engines failed, the auxiliary power unit would be an extra source of electrical and also hydraulic energy to be able to move the flight controls. And this has happened. It was the case of the landing on the Hudson River. But why are they installed in the tail of the plane? It should be noted that a turbine generates noise, so the aim is to keep them as far away from the passengers as possible, and also there at the back, they do not generate air resistance as if they were in a fairing on the wing, for example. Also, if a fire occurred, it would not impact the plane's more critical areas. The gas outlet can be seen in most modern commercial aircraft as a small tube coming out of the tail. What you see here are the air intakes that some airplane models use. As it is used for the production of alternating current in the aircraft, the output is 115 volts at 400 Hz, which is the current used in airplanes, instead of the 50 or 60 Hz of your home's electrical grid. An auxiliary power unit, like the one in the Embraer E-Jet, consumes about 2.4 kilograms of fuel per minute on the ground, this producing the maximum amount of air bleed, which represents 144 kilograms of fuel every hour. Flying at high speed and altitude, this value is greatly reduced to about 0.8 kilograms per minute. The Boeing 727 in 1963 was the first jet to incorporate an auxiliary power unit, allowing it to operate in small airports regardless of the facilities they had. There are two world leaders when it comes to APUs. One of them is Hamilton Sandstrand, which equips, for example, the Embraer E-Jet with its APS 2000 models and the Boeing 787 Dreamliner with its APS 5000, among many other planes. The other major manufacturer of APUs is Honeywell, with over 100,000 in 1,000 APUs produced and over 36,000 in service today. In the case of the APUs, the Hamilton Sandstrand APS 2300 model develops a power of about 600 HP and is made up of two axial turbines that have constant speed. These move a centrifugal compressor through a shaft. The gearbox is moved by that same shaft, reducing the speed in order to be able to couple it to an alternating current generator with its own oil pump to cool it. I thank Manuel Represa from the blog The Flight of the Great Bustard, where I base myself to make these scripts. I hope you liked it. Remember that you can leave me in the messages what topic you would like to see in future videos. Until a new installment of Aviation World. Thank you.